Good evening, and welcome to our second video on hypothesis testing. In this second video, we're actually going to do some calculations in order to do hypothesis test. What we would do first is we would read the claim and establish the null and alternate hypothesis from that. Then we would check their evidence, which is sample mean, standard deviation, sample size, to come up with a z-score. Look the z-score up on our chart to find the probability or p-value. And then we decide who's bigger, P or A. A or alpha is a value that I have to give you. This is required. What it is officially is the probability of committing a type 1 error. But we'll get into that a little later. But that's something we need, and it's something I give you. You don't figure it out. Well, anyway, and then once we decide who's bigger, then we can choose one of the four choices for our conclusions. Like everything in this course, it's easier to show than explain, so let's do some examples. So our claim is that U is less than 13. We have a mean of 12.7, standard deviation 1.2, size 50, and alpha is 0.05. Okay, so HA is U is less than 13. Okay. And that's because of the less than sign. So by default, the null is U is greater than or equal to 13. And let me get that equal sign in. There we go. Okay. What's next is we're now going to find our z-score. So, using the formula here. So, let's see what we have. The mean is 12.7 minus the claim, which is 13. We're going to divide that by the standard deviation, which is 1.2. And then when we're done with that, we're going to multiply by the square root of 50. So let me fill in some important lines. So like this. And for that, we can find our z-score. And our z-score is equal to negative 1.77. All right. So our z-score is equal to negative 1.77. So I want to look that up on the chart. If you look that up on the chart, we're going to get a p-value of 0.0384. Okay, it's now time to make a decision. Who's bigger, P or alpha? Well, let's see what we know. I'm going to type them right next to each other. P is equal to 0.0384, and A is equal to 0.05. Well, to me, it looks like A is bigger. And if A is bigger, that means we have to reject. Okay. All right, so when we make the choice, it's either going to be A or B, because they both say reject. So the tiebreaker is, what's the claim? Well, the claim said less than, so I guess I'm going to go with A on that, because it has that less than sign right there. So that means there is enough evidence to support the claim. I know this is a little confusing right now, so let's do more examples. Okay, so for example 2, our claim is U is less than or equal to 24. Well, guess what? Right away, I can tell you that that is going to be the null hypothesis. And I'm going to type that in. So that is going to be U is less than or equal to 24. And I do have to fill in the line. There we go. So that means by default, our alternate is U is greater than 24. All right, good. Now that the hypothesis is done, let's find the z-score. So, we know that the mean is 25.1. The claim is 24. The standard deviation is 2.6. And our sample size is 19. Let me fill in some lines. So, fraction sign here, square root right there. Let's see what we get. We're going to get a z-score equal to 1.84. Okay. So right now our z-score is equal to 1.84. But don't forget. So I want to look that up on the chart. Yeah, don't forget. We're going to look it up on the chart. Okay. And if you look that up on the chart, you get 0.9671. But don't forget, this is a right tail test. And right tail is just like dealing with more or greater than. Right tail means we have to subtract from 1. So we're going to do 1 minus 0.9671, and that's going to equal to 0.0329. All right, so let's see what we have here. We have P and we have A. I'll type it up again. All right, P, we just figured it out. It was 0.0329. A is given, it's 0.01. So decision time, who's bigger? And to me, it looks like P is bigger. Whenever P is bigger, that always means fail to reject. So our choices are either going to be C or D. Since our claim was less than or equal, it looks like our choice is going to be D. All right, very good. Let's do some more. The claim is U equals 1200. Because of that symbol right there, that is our null hypothesis. I'm going to type that in. So by default, our alternate is U is not equal to 1200. And I'll put the slash mark like so. Let's do it better. There we go. That's better. And with that, let's find our z-score. So our mean is 1170 minus the claim, 1200. We're going to divide that by 95. And then we're going to multiply that by the square root of 24. Let's see, get the line here. Square root there, good. And for that, the z-score is equal to negative 1.55. Okay. Now the next step is to look up negative 1.55 on the chart. And if you do, you get 0.0606. But don't forget, this is a two-tailed test. And when you're dealing with a two-tailed test, that means we have to multiply whatever we look up by 2. And if you multiply that by 2, that means our p-value is going to equal to 0.1212. Okay, now that we got our answers, let's make a decision. P is equal to 0.1212. Alpha is equal to 0.05. And by the looks of it, looks like P is bigger again. So that means we're going to fail to reject. And since the claim was an equal sign, it looks like we're going to choose D again. All right, very good. Let's do some more. Okay, suppose a teacher claims that the average test score is more than 80. All right, right there, more than 80, that's our claim. More is the same as greater than. So what that means is this is our alternate hypothesis. And I'm going to fit that in right now. So for our alternate, U is greater than 80. By default, that means the null hypothesis is U is less than or equal to 80. And let me fit that line in. There we go. So that part's over. Now let's find our z-score. So let's see, our mean was 84 minus the claim, which is 80. We're going to divide that by the standard deviation, which is 11. And then we're going to multiply by the square root of 19. So let me fit some things in here, here. And it looks like our z-score is equal to 1.59. All right, very good. Let me go over here for a moment, cross this off. Okay, let's look this up on a chart. And if you do, you're going to find that on the chart, we get 0.9441. But don't forget, this is a right tail test. So right tail means p is going to equal to 1 minus 0.9441. So that means p is going to equal to 0.0559. All right, good. Time to make a decision now. So we know that p is equal to 0.0559 and alpha is 0.10. So this time it looks like alpha is the bigger number. And when alpha is bigger, that means we're going to reject. So it's either going to be A or B. The claim was greater than, so I'm going to go with A for that. Very good. All right, let's do one more example. Suppose Ben and Jerry claim that the average annual ice cream consumption is 20 pounds. Notice not what you read, but what you didn't read. You did not see less and you did not see more. If you don't see less than or greater than, then that means this is going to be a case of equals. So that means our null hypothesis is mu, or u, is equal to 20. So by default, our alternate hypothesis is u is not equal to 20. And let me get that line right there. There we go. So it's a two-tail test. Let's find the z-score first. All right. So our mean is 17 minus the claim is 20. We're going to divide by the standard deviation, which is 9. And then we're going to multiply that by the square root of 26. So let me put in the fraction. Let me put in the square root. And for that, our z-score is equal to negative 1.70. Okay. All right, next we're going to look up negative 1.70 on the chart. If you do, you get 0.0446. Okay, that's terrific. But wait a minute. This is a two-tail test, isn't it? So two-tail means we're going to have to do times 2. So when you do that, our p-score is really 0.0892. Okay, it's time to make a decision. All right. P is equal to 0.0892, and A, I told you, is 0.01. Once again, it looks like P is the bigger number. And when P is bigger, that means you're going to fail to reject. Since the claim is an equal sign, it looks like I'm going to choose D for this. There is not enough evidence to reject the claim. All right, very good. Of course, sometimes mistakes are made, and there are two types of errors, type 1 error and type 2 errors. Type 1 means you reject the null when the null is true, and type 2 means you fail to reject the null when the null is false, or if HA is true, the alternate is true. So to do this, here's how you would do. First, set up the null and alternate hypothesis, and then follow the template. Whenever they ask you to write the type 1 error, always write reject the null even though it is true that whatever the null is. In example 6, the null is 0.75. So we would say reject the null even though it's true that 75% of high schoolers graduate. And then type 2, you would say fail to reject even though it is false that 75% graduate. Something like that. Anyway, that concludes everything you're doing in Chapter 7, so you should be able to finish the Chapter 7 homework. If you have any questions, please let me know. Otherwise, have a good evening.